So to understand quantum tunneling, we can first use a similar example, but instead using classical physics. So, for example, as we see in this animation, there is a ball that is trying to get through a barrier. For it to pass through the barrier, it needs to be given a certain amount of energy to get over it. But in quantum physics, if we look at things such as an electron passing through a potential energy barrier, there is a probability that the electron can pass through the barrier and end up on the other side of it.
In the wave function diagram, we can see a wavelength, which we will label. The first part of the graph is the wave function incident, and it has a larger wavelength than the wave function exit. This is not because of reduced energy, but the reduced probability of the uncertainty of the electron. So in this, after the electron passes through the barrier, we have a lower uncertainty of where it will be, and therefore a higher probability of its location.